Okay, so we looked at the periodic table. We were able to identify metals, nonmetals, metalloids. Let's talk about their properties so you know the differences. So metals are, the first property is what we call malleable. Malleable means they can be bent into shape. Okay, and that word comes from the term mallet. Like a blacksmith would take a mallet, a hammer, and make horseshoes. He would take a piece of iron and keep hitting it while it was hot and make it change its shape. So anything that can change its shape by hitting it with a mallet is called malleable, right? It basically means it's bendable, right? Shapeable. Ductile means you can make wire. You can pull on it, and it will get thinner and thinner and thinner, and you can make a wire out of it. Doesn't really seem that way, but with metals, some metals are better at this than others. Copper is really good at making wire. Okay. Metals are shiny, but you knew that. Everybody knows that metals are shiny. Metals conduct heat and electricity, right? So frying pans, the first frying pans that existed, they didn't have plastic or wooden handles. It was just a solid piece of metal. So when you grabbed the frying pan, you had to hold like oven mitts to hold the end of it. If you go into like a really fancy high-end kitchen, like master chefs like the purity of solid metal pans, and so they always use the mitts to grab them, right? They don't, because the ones with handles that are plastic and wood, they tend to be cheaper and they tend to be not be made of pure metals, which don't transmit the heat as well. So that's why they choose the higher end stuff. And metals are mostly solids at room temperature. There is one metal that is not solid at room temperature: mercury. And we know that mercuries are located on the left side of the table, left side of the stairs. Okay, so then let's talk about the properties of nonmetals. Essentially, the properties of nonmetals are almost exactly the opposite of metals. So they're non-ductile, which means you can't stretch them. And for that matter, they're not malleable either, so they can't be shaped. They're not shiny. Luster means shiny, so they're not shiny. They do not conduct electricity or heat. Most of them are gases at room temperature or solids at room temperature. If you look on the periodic table right on top, you see all the letters that are black? Black means solid at room temperature. Anything that's red means gases at room temperature. And then there's a couple of blues, because blue means liquid at room temperature. So there's one non-metal that's liquid at room temperature. What is it? Bromine, Br. Anyone see that? Okay. Nonmetals are located on the right side. So metalloids, or known as the semi-metals, they usually exhibit half and half. Some properties of metals, some properties of nonmetals. Conductivity is the one we look for. All right. The type of bonding, though, is the same as what nonmetals have, and it's located on the staircase. So those are the properties of the elements. Now, probably one of the main reasons why we even teach you guys electron structure is to focus on the fact that if an element is in the same family, they will have similar chemical properties because they have similar electron configurations. And really, the electron configuration, the most important part of it is the ending. So the fact that these alkali metals, their electron configuration all ends the same way. It all ends with one electron in an s sublevel. This means they have predictable reactivity. The fact that they're all ending the same way. Okay, so last two terms. Valence electrons are the electrons in the outermost energy level. So effectively, what that means is this. If we go back to our electron configuration for sodium. Ooh, sodium is missing something. 2p6. In your electron configuration, the number in front of the letter indicates the energy level. So in sodium, how many different energy levels does it have?
3.
It has 3. 1 and 2 and 3. What number is the highest? 3. Okay, so since in sodium, energy level 3 is the highest, how many electrons are in the highest energy level? Just 1. Sodium has 1 valence electron. The valence electron are electrons in the highest energy level. What about potassium? What is potassium's highest energy level?
4s.
4, right? And how many does it have there?
1.
1. Oh, it's the same as sodium, but that shouldn't be surprising because of the same family. Rubidium, what's its highest energy level? 5. And it's got 1 electron there. It also has 1 valence electron. The point is, if they're in the same family, they will have the same number of valence electrons. They will all have only 1. If those are valence electrons, the other term for the electrons that are tucked away and not on the outside is what we call core electrons. These are electrons that are underneath and they're closer to the nucleus. Core electrons are not exchanged during chemical reactions. Because they're not accessible. They're too tucked away. They're too hidden. Only valence electrons are exchanged during reaction. All right, so if we look at silicon here, this is the SPF notation. How many electrons are core and how many are valence? So first off, ask yourself, how many levels are there? How many energy levels are there? So energy level 1, energy level 2, energy level 3. That's 3 energy levels. What is the highest? 3. How many electrons are in the highest level? The highest level meaning both 3s and 3p combined. Right, 4. So 4 valence electrons. And that means the rest, these guys, are considered the core. So 10 core electrons. Do you guys see how I'm doing this? When you write an SPDF notation, the highest energy level, those are going to be your valence electrons. Everything else is considered the core. So let me just do another 1 or 2 just so you get the idea. So arsenic. I'll do long way just to prove a point. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, no, just kidding, 4p3. Okay. What is the highest energy level that you see?
4.
4. Here and here. So if you add up the highest energy level electrons, we have how many valence electrons? 5 valence electrons. And that means the rest are core electrons, right? So the rest of these are the core electrons. You guys see how we're doing this? So yeah, 20, so it'd be whatever's left, right? Okay. And, let me just do one more for you just to get it done. Okay, barium. Actually, I'll use shorthand for barium. We'll go xenon 6s2. What's the highest energy level you see? 6. And so, how many valence electrons are there? Just 2. And then the rest. So there's 56 electrons in barium. 54 of them are core. 2 valence electrons. Okay. All right. We did a lot today.